Hi, and welcome to the mathematics portion of this channel. And this is going to be a two-part series where we cover two topics in linear algebra, and that is vectors and matrices. If you are here from the OpenTK 2D Game Engine / Framework series, feel free to skip this video. It is optional. But before we get started, I think we need to address the elephant in the room. Why the hat? Why the sunglasses? Why the mask? And why the sleazy pink shirt? And that's a really good question. Let's start by defining what a vector is. A vector is made up of two things. So we have vector, and that equals what? A magnitude and a direction. And that's what gives us a vector. Now you might be familiar with direction. You might be familiar with concepts such as a 2D vector and a 3-dimensional vector, but this is not exactly the same thing. They are tied together, but a vector is just made up of simply a magnitude and a direction. Its position does not matter. That is not something that we care about. The only thing we care about are these two values. So what I mean by that is, let's say I have my normalized device coordinates here. So we have 1, 1, negative 1, negative 1. And I define a vector at starting here and going up in this direction. As long as this has the same magnitude and direction, that means that this value over here, we're going to pretend that these are the exact same length, okay? These are actually the same value because we haven't factored in what the position is at this point in time. So you can do multiple things with vectors. You can add them, subtract them, and multiply them. So let's see how we would notate about vectors. The way that we represent them is you simply represent them by a variable letter with an arrow over it. For example, if I have vector A, I would point it to this direction. And then vice versa, if I had a vector called vector B, it would be B with the arrow across. So let's go ahead and define these vectors on here so we can kind of visualize how the addition works. So let's say vector A is going to start at, it's going to go to 1, negative 3, and it's going to move it's going to move 1 here, so it'll go to 2, negative 2. And then if we had vector B, let's say vector B is, I don't know, let's go with negative 3, negative 3, negative 2, to negative 4, negative 3. So how would we add these two together? Well, one thing to keep in mind is A, in this instance we're taking A plus B, so we have, I'll switch back to black here. So our question we're trying to answer, what is A plus B? There's definitely something that you have to take into consideration here, is that in normal addition, you don't really have it doesn't matter. If you say 1 plus 2 or 2 plus 1, they're both going to give you 3. That is not the case for vector addition. So let's say what we're going to do this addition here. Wow, I cannot speak. Remember how I said earlier that the position does not matter. All that matters is where is it going and where do we start it at. So we're free to move these wherever we want without causing any issues or affecting the equation. So let's do that. So we're taking A plus B. So we're going to start with vector A, which is here. So we go to its tail, and then we go to vector B. So vector B, we can simply move this to here, and that's going to point right back. That is a horrible example. Let's make it a little more interesting. Let's instead make A equal to, we'll keep it at 1, but let's just move it over 3. So it's going to move to 3, negative 3. And now we want to add B to this. So what we would do is we would just simply take B, and we're going to slide it over to the tail. So that would be right here. And we're going to move it in the same magnitude and direction. So we're going to move it 1 to the left and then 1 down. So 1 to the left and 1 down, which puts us right here. So that's That is what, then that becomes, so let's see, negative 2, 2, negative 4. And then that is our final answer. Let's prove this in an algebraic way. We'll wrap that up. That's how we're going to wrap this video up. So let's say we have vector A, and that is going to start at position 0. We're just going to assume both of these vectors. We're starting at position 0, so we don't have to move them around. It's going to start 0, 0, and it's going to go to 3, negative 2. So it ends right here at 3, negative 2. So 3, negative 2. And then we'll have vector B, which will go to 2, negative 1. A little too far there. So, yep, let's add this here. So 2, negative 1. Simply take A plus B. So it becomes 3 plus 3 plus 2, and we get 5. So that will be one of them here. So we get 5, and then negative 2 plus negative 1, which gives us negative 1. So if we were using the visual representation of that, that means it should end at 5, negative 1. Let's move it right here to take an A. We're going to take the tail of B, move that up here, and that puts us right here. And then there we go. And then that is our answer, and we can validate that it ends there, and we get 5 and negative 1. So you can also do multiplication with vectors. And what you can take it by is a scalar value. So let's say, for instance, we want to take, black is good. We can use green, actually. Let's say we want to have 3 and negative 2. So 3 and then negative 2. That puts us right here if our origin is 0. And we want to take 2 times negative, our value here, so 3, negative 1. We just simply multiply it by each. So 2 times 3, that gives us 6. 2 times negative 1, and that gives us negative 2. So we have just simply doubled it. So we've taken this length and we've doubled it to 6, and then negative 2, which is here. So we've just taken this and we've doubled the length of it, and that brings us to our final value. So we're going to wrap this episode up here. I'm not going into great detail. I'm just trying to give you a very high-level overview of how all of this works, because we're still just going to use, if you're following any of my courses related to graphics card programming, we're going to stick with just using OpenTK's mathematical library, or GLM for using OpenGL for when we start diving into C++. If you like what you saw, please like and subscribe, and I will catch you in the next episode. Thank you.